Okay, so it looks like it's working. All right, so today we're going to start on Chapter 1, and this is an introduction into networking. We're going to talk about the advantage of computing-related networks versus standalone networks. We're going to talk about client-server and peer-to-peer, which are two different types of networks. And we're going to list some of the elements that are common to all of the networks. We'll describe several specific uses for a network. We'll identify some of the certifications available to networking professionals. And we'll talk about them all, but primarily we're looking at Network Plus, which is the goal for all of y'all. And we will identify the skills and specializations that will help you excel as a networking professional. All right, so why use networks? Well, that's kind of a simple question, really. We've reached a point in technology where so much is on a computer. I think I've used this example maybe with y'all before, but I know with other classes. Think about a bank. Your bank says you've got $1,000 in your account. That doesn't actually mean the bank has $1,000 reserved for you anymore. It means that a record in a database says that you've got $1,000 that bank is holding for you. It's all just zeros and ones in a computer. And that information is even more usable when it's shareable. If banks weren't able to share data, for example, and you've got a Capital One account on Uri Drive and you want to write a check to the Capital One out on North Market, well, they're going to have to call down there and see if you've got that money and have it recorded and all of this. And with a network, it's just a simple matter of them running it through their computer, and there it goes. Oh, you've got the money in your account, even though it's over there. Here it is. And I used an example at North Market, but that's the beauty of a network. It doesn't really matter. If there were Capital One in Canada and you happen to be up there, you could do the same thing. Networks bridge computers over, small and vast distances. So a network is a group of computers or devices connected by some sort of transmission media. And they use transmission media to mean copper or fiber, but now it also means wireless. So that's something to always consider. People, when we talk about this, will say physical media. Even though wireless is not anything physical, it is a type of physical media because it is still a way. It is still a way that you're connected, even though it doesn't use any wires. So advantages of networks are that it gives us a way to share things, and that ultimately saves time and money. And on a large network, you have central network management. Like thinking about the computers here at BIPSI, imagine the trouble it would be every time BIPSI needs to install new software if somebody had to go around to every single computer on this campus and install it. Like, let's say when they get ready to update Word, if somebody had to go do that on every computer. Well, a central network allows you to manage it without doing that. So the types of models of different networks vary according to where the computers are at on the network, the control levels over the shared resources. That means, are we letting every user decide what to share, or is it being done centrally? Or the communication and resource sharing schemes, and we'll talk about those later. Two big network models to know are the peer-to-peer and client-server. And in a peer-to-peer network, you have what is called equal authority or direct computer communication. Peer-to-peer is probably what most of you have at home if you're sharing like a printer or other device. There is no central server in a peer-to-peer network that controls things. Individual resource sharing happens on a peer-to-peer network. And what that means is each user determines what to share. If we had peer-to-peer in here, you would set on the computer you're at what you're going to share. You would determine those rights of what you're going to share with the rest of the group. In the traditional model, it's two or more general-purpose computers capable of sending and receiving information to and from every other computer. Here is their picture of just kind of a graphic idea of a peer-to-peer model. No, we wouldn't get into, well, a router would be a larger network, but it could, I mean, peer-to-peer wouldn't matter on a router. It could, if you're controlling the resources, that's all that matters. Whether there's a router or a switch in it or in the middle, it wouldn't matter at all. The advantages of peer-to-peer are they're pretty simple to set up. Windows has built-in peer-to-peer network sharing. All you got to do is turn it on and decide what you want to share. So they're also less expensive because they don't need that central server. The disadvantages, though, are that they're flexible. They're not very flexible. As the network grows, setting up a peer-to-peer network becomes less and less practical. And they're not necessarily secure because your users have access to determine what to share, not a central administrator. One area that, like, for example, one reason that networks of a different type are popular in a place like this, a campus, is usernames. All right, we've got a relatively small class here. If I had to go around to every computer in here and put in usernames for y'all, that wouldn't be a big deal. But think about BIPSI as a whole. If there wasn't some sort of central management, every time a new student started at BIPSI, they'd have to go to every computer in every lab on the campus and add that user to that computer. You know, it would just be absolutely impossible to manage. So the resource sharing method on peer-to-peer networks is the user's responsibility. It is not centrally controlled. Peer-to-peers are typically small home or office. And then also you have another branch of peer-to-peer networks that are very large using the internet. And that's like your BitTorrent software and networks like Nutella and Bitcoin. And originally, before it's changed, Napster. Client-server networks are more of what you see in medium and large businesses. And in a client-server, you have a server that is a central computer that facilitates communication. And then the clients, which are sometimes also called the workstations, are all of the individual computers. In this type, central resourcing is controlled by the server. There is no sharing of, users don't individually share things. There's a server.
You can have more than one server, correct?
Oh yeah, you can have tons of servers on a network. So the roles, the server and the client runs the local application, stores the data, uses the server for shared applications, and uses the server as an intermediary. And they're connected with switches or routers. Here's their example showing a client-server network, and we've got a file server on here, and we've got some computers that are connected to it. Maybe a printer is connected to it. Most client-server systems are going to use some sort of management tool on the operating system on the server. And for almost all practical purposes at most businesses, that's going to be a Microsoft server. So if it's a Microsoft server, all of this is going to be connected with what's called Active Directory. And Active Directory is what we use here at BIPSI that has all of you as users in it. It's what allows you to log in on that computer with your username or log in on one on the back row without someone having to go to that actual computer to put you an account in it. So the server must have a network operating system. The network operating system is what's going to manage the client data and the resources. It's going to ensure that the users that have access do have access and that users who shouldn't don't. It will restrict the user access. It dictates what the communication rules are for the network, and it supplies applications to clients. There are more servers than Microsoft Server. As you hear more and more about me lecturing in classes, you'll find I'm a big fan of Linux. I teach our Linux classes. Microsoft Server is still definitely the biggest one. And there's several reasons for that. Linux is very good, but Linux doesn't come with the support that Microsoft does. So a lot of your businesses like that support that they can get from Microsoft. And even OS X, if you've got Mac, a complete network of Apple computers, there is a Mac OS X server. Servers generally are more robust in their design than a client. They usually have more memory and more storage capacity. which makes them, more expensive. They usually have network management functions, like you may have a server that's got more than one network card in it. So it can communicate with more than one separate, physical network. They're usually a little more complex in design than just a regular computer. One of the big keys to a server is to put a lot of memory on it and put, a big hard drive on it, because it's going to be holding data from all of the other computers. So, other advantages that a client-server network has over a peer-to-peer. User credentials are assigned from one place. That's where I was talking about Active Directory coming into play, where all of your accounts are on one server downstairs. Well, it's actually multiple servers here. But that way, when you log onto a computer, you don't have to have your information there. If any of you were to hit Control-Alt-Delete now and change your password here, it's going to change it in that central place. That way, when you go log into another computer like in 203, your new password is there. It also allows for central problem monitoring, diagnostics, and correction capabilities. Client-server networks, finally, are way more scalable than peer-to-peer networks. So, local area networks are networks confined to relatively small spaces. These became popular kind of in the 80s when Windows 3.11 first came out. That was one of the first Windows operating systems that would connect computers together. And they were peer-to-peer networks basically then, because you didn't have a lot of central servers. Today, there are much larger and more complex client-server networks. Another term to be aware of, specifically because you might see it on the CompTIA test, is the metropolitan area network. And that is a network that connects clients from servers to multiple buildings. It uses different technology than a LAN. Technically, what we have here at BIPSI is a metropolitan area network, because we have all of the buildings connected together. Now, the reality is that you never ever in the real field hear anybody use the term metropolitan area network. Basically, you use the terms LAN and WAN. And a LAN means it's a local network, and if it passes through a router and connects to somebody else, it's a wide area network. Like you'll notice when I talk about the network here, or if I give examples of the network that I worked on at BIPSI or at LSUS or at Tech or Northwestern, any of those, I'm going to refer to the campus network as the WAN. Even though technically, according to CompTIA's definition, it's a metropolitan area network. And I want to make that distinguishment for y'all, because I know most of y'all are looking at this field planning on going into it. So you got to know that metropolitan exists for the test. If they give you a definition of a network and it's buildings like this, it's a metropolitan. But in general, it's going to be called a WAN by almost everybody.
Is that ruled as a WAN because you can add satellite to it as well?
It wouldn't matter what kind of transmission. It's just called wide area because it spans more than one network. A WAN is just a connection of local area networks. But in their definition, a WAN is a connection of metropolitan area networks, which are ultimately a connection of local area networks. So here, a wide area network connects two more geographically distinct LANs. It uses different transmissions. Network connection, they say separate offices in the same organization or separate offices in different organizations. One of the reasons that WAN is used primarily when you're talking about these larger networks is that there's no distinct definition of where a metropolitan area network stops and a wide area network starts. In the terminology, it's unclear as to where the line would be. Like, technically, what is a geographic location? If I've got an office on one side of Texas Street Bridge and one on the other, and I convince the State Department to let me run a fiber under the bridge, what kind of network is that? Is it wide area or is it metropolitan area? Because it's close together, but Shreveport and Bossier are technically two different areas. So that's the reason that people out in the field just don't use that term. Here's their example of a wide area network. You see they've got some computers, they've got a router connecting to another router, which just connects the two networks together. So elements common to a client-server network. You're going to have a client, which is going to be the network computer requesting resources. You're going to have the server, which is going to be the network computer managing the resources. And then a workstation may or may not be a connected network. Most of the time, the workstation and the client are going to be the same thing. So other elements that are common to client-server networks, you're going to have some sort of device to connect the computer to the network. And that is called the NIC, or the network interface card. It's usually inside the computer, and it connects to the media, whatever media it is you're going to run the network. Now remember, media might be wireless, so it might just be that it connects to an antenna. And that allows communication with the other computers. Then you're going to have some sort of network operating system, which is going to be your server software that's going to enable the server to manage the data, the users, the groups, the security, and other functions. Here they're showing just a picture of a motherboard. And this is important because most network interface cards now for clients and for workstations are built onto the motherboards. It's not very often that you actually need to put a network card in a computer anymore, because almost all modern motherboards are going to have one built into them. You would only need to add one if it were for some specific reason, like, you know, the one built in here, that's going to take copper wire. But if we wanted to be able to use fiber, we might have to add a network interface card that had a fiber interface on it. So a host is a computer. It enables the network resource sharing by other computers. A node is a client, a server, or other device that communicates over the network. Every node on a network has a unique address. So basically anything connected to the network is going to be a node. That printer could be considered a node. My laptop right now, even though I'm wireless, it's a node. All the computers y'all are on are nodes. And the connectivity device is what allows the multiple networks or multiple parts of one network to connect and exchange data. So your connectivity devices are going to be things like your switches, which all the computers are connected to, and then a router, which connects more than one network together. So a segment is a group of nodes that use the same communication channel for traffic. A backbone connects the segments and significant shared devices. So like in this terminology, this lab could be a segment, because we've got one switch back there that all the computers in this room are run to. And then the backbone is typically a faster network that connects the networks together. In the example earlier where I talked about the wide area network here at BIPSI, the campus backbone is the fiber that runs between all the buildings that connects them together. And then finally, topology refers to how the network is laid out. And there are different types of those, and we'll talk about them. A ring, a bus, a star, or hybrid are some of them. Here they're showing the backbone is the wire that runs from the router between the two switches. So here are some of the different topologies, and further along in the class we get into details on each. But a bus is run where all the computers are connected with one wire, usually a piece of coax. A star, which is what we have here, all of the computers are connected to some sort of intermediate device, in this case a switch. There's actually a wire that runs into the wall from every single computer in here, and if you look back there in the back, they come out on the top. The switch is on that little rack stuck up on the top of the computer rack there. Ring is one that lost popularity on local networks but has gained popularity in wide area networks. And in a ring, every computer is connected to the two computers closest to it. And rings are actually a little bit faster than stars. as far as network, but they're not used anymore because cabling for a ring is very difficult. If this lab were wired as a ring, for example, every computer would have to be connected to every computer next to it. And then the last two computers would have to be connected together. That's fine when it's in one room, but imagine this was an office building. Difficult to wire, and then say that we want to add a computer. We put a new office in over there. Well, now I've got to run a wire from that existing ring onto that computer, and then one from there back to the next computer. So they're just hard to wire. And then a hybrid, which is more common, is combinations of those networks. You don't see hardly any networks that are pure any of these anymore because different ones are connected together. Elements that are common as well, a protocol. And a protocol is the standard method for communication between network devices. And the way that I tell students to think of a protocol is think of it as a language. We've got to have a common language in order to communicate. A protocol is just that. And it's okay if there are different protocols on the computers as long as they have one that's in common. For example, if all of you spoke only Spanish and I spoke only French, we would have no way to communicate because we don't have anything in common. But if I speak French and English and all of you speak Spanish and English, we're still okay because we've got English in common, so we're able to communicate. That's our protocol. And the protocol is just that. It's the language that determines how things communicate. You know, if you think about in English, the protocol is, you know, how do you put sentences together? What are the words that we all know? Things like that. It's the exact same thing in a protocol. It's the rules that allow the computers to talk. A packet is a distinct unit of data exchanged between nodes. Packet is what we actually send out on the computer, on the network. And you'll see that when you request something like a web page, normally it's not just one packet, it's several packets. That request to get that web page off a server gets broken down into little bitty pieces, and those are sent out on the network. And then it comes back in little pieces with the response, and it gets put back together before it's displayed on your screen. Addressing is the scheme that you're going to use to identify the computers. On a network where there's multiple computers, there's got to be some way to identify everybody. You can almost think of an address kind of like a name. I'm able to identify you individually because you all have a different name. On the computer, it's the same thing. The computer has an address that lets it know that data is sent for it, not for another computer on the same network.
Is that the same thing about the IP number?
An IP number is a type of address, yes. There are two different types of addresses, and we'll talk about them later, but an IP address is definitely one of them. And then transmission media is the means through which the data is transmitted and received. For these computers in here, that's the copper wire I was talking about, but it might be wireless. It could be fiber, it could be a satellite, it could be anything. Here are an example of some of the major types of media. You've got coaxial cable up at the top. They gave an example of shielded twisted pair. Most twisted pair wire is not shielded. Most of it is unshielded. But this is just one type. And then fiber optic. And further on, when we talk about different media, we'll talk about each of these in more detail. And then what's more common now than ever is wireless. How many of you have a wireless network at home? Almost 100% of the class. So that is something that's more and more common because wireless allows us to be able to move around with our computers in ways that we couldn't before.
Is that wireless faster than fiber optic?
No, wireless, fiber optic is always going to be the fastest. Wireless is the slowest of all of these. But we are willing as a people to accept it being slower because of the ability of not needing a wire. For what most people do, it's fast enough. It's never going to be as fast as copper, which is never going to be as fast as fiber. So there are many different ways that networks can be used. But just a few examples. Printer sharing is a big one. We only have 2 printers for this room, but all of you can print to them because we're able to share them. Email is a big one. File sharing, internet access, remote access. Something that's kind of a new area you're seeing more and more of now is voice and video services over the network. and network management. So file services is the capability to share data, files, and applications using the server storage space. That's one of the main reasons networks came into existence. Businesses wanted a way to be able to share something so that multiple people could view it. You know, in the old days, even before Microsoft Office, people used programs like Corel and other spreadsheets, and being able to store those spreadsheets on a server so that the boss could look at it and see what the production numbers were, or if you were sick, the other person that works on the spreadsheet could enter data in it. That's why servers really came into being. And then print services, because it saves money and time. We very seldomly print anything in here, so there's no reason to have a printer on every single computer. Access services allow remote users to have network interaction. It allows network users to connect to machines outside of the network. And a remote user is a computer or user on a different network or in a different geographical location from the server. Network operating systems include built-in access services. Access services provide LAN connectivity when a WAN connection is not cost-effective. That is like if you have a VPN, a virtual private network. If you only have one user at a remote location, it is much cheaper for you to get them an internet connection and use a VPN than to actually run a wide area connection from your office to their individual office. They allow external users to use network resources and devices. So something that you're going to hear a lot of that's kind of a new term, relatively new term, is convergence. And convergence is the offering of multiple types of communication services on the same network. What we mean by that is that we now have networks that have more than just data on it. It's not uncommon for a network to have telephone traffic and data and video all on the same network. One of the best examples I can give of convergence, we don't have it here in Shreveport, but if you live in a larger city, Verizon offers a service called Fios, which is fiber to your home. And that one fiber has your telephone on it, it has all of your TV on it, and your internet access on it. Those are becoming more and more common because the lines between all of those services are blurred, especially with things like voice over IP telephones, which we'll talk about later. But that is using your telephone over the internet, which a lot of people do now. Skype, what's some of the other ones? Vonage, all of that is telephone over internet. And then email, which is something that, everybody uses. So additional tasks of mail servers might be to intercept spam, handle objectionable content, route messages according to rules, provide web-based clients for checking the email, and notify administrators if certain events occur, such as if a user is sending out spam or they're getting a lot of viruses or something like that. Mail servers run on specialized mail server software. A web server is something else you might want to run. And a web server is what you connect to with Internet Explorer, Chrome, or Firefox, whatever you're using. One of the reasons for the explosion of the internet the way it is because of web traffic. People are able to find information on just about absolutely anything these days. It's kind of scary, but I honestly can't even think of a topic that I couldn't put into Google and Google tell me something about. If you spelled it right, there's probably a web page somewhere out there about anything you can imagine. Yeah, if not, it's going to be in the suggestions. I'm a horrible speller, and if I don't have Word, I have been known to open Google and type in the word to search for it. So it'll say, "Did you mean?" And I can write that down because I got it spelled right from Google. Other things that do happen on the internet, though, file transfers, security filters, and a means for directly logging in on other internet computers. So, based on what the network is and how it's designed will be how the network is managed. It might be a small network where you are the only network administrator. When I was at the juvenile court, that was the case. I was the only person, so I made all the decisions on how to set up everything. I was the only one there. In a larger network, you might have more than one administrator, and that's where documenting things really becomes important. I should have documented everything at the juvenile court, but if I didn't, I was the only guy there. I knew it. That's all that mattered, because I was the one making changes to it. If I'm in a bigger network where they've got more than one administrator, like at LSUS, I shared it with one other person. It was important that we made sure we at least communicated with each other on a very regular basis so that we knew what the other one was doing. A, so that we didn't do something twice, or B, so that if he was working on one project going one way and I was going another way, we at least made sure we had a way that both would work together. Some of the management services that you would do on a network are traffic monitoring. Load balancing on a big network is important. And do y'all know what load balancing is?
Make sure I don't overload server, taking in too much information.
Basically, load balancing is where you have two servers that have the same thing on them, and the one with the lowest traffic load gets the request. Google uses load balancing, in amazing ways. When you you go to google.com and type in a search, you don't know, because of the way Google set up, what server it went to. There's not just one computer that goes, when you go to google.com, it's not one computer you're going to. It's actually one of several 100,000 computers that you might be hitting on the internet. Other things you might get with management are hardware diagnosis and failure alerts. You can do asset management and license tracking, where you keep up with the computers that are on your network. And then backup and restoring of data. So, becoming a network professional, that's why most of you are in this course. There are many job postings for computer professionals. Expertise levels vary. To prepare for entering the job market, have a master general networking technology idea. Select and study areas of interest. The days of just being a network person are almost gone. You've got to kind of pick a specialty now. And that is a change from even just when I got a degree at Northwestern back in '96. I just got a degree in CIS, and that was everything. That was networking and a little bit of programming and everything. Well, we saw the split there to programming in one side and networking in one side. And now, because absolutely everything is networked, you can specialize in that. Do you want to go into network security? Do you want to go into file management? If you're at a small shop, you're going to be everything. But if you're in a big network, let's say you got a job for like LSU, the main campus in Baton Rouge. Well, they're going to have network administrators that do very specific tasks. Like they probably have someone whose sole job it is to just manage Active Directory for that big of a campus. They're going to have one person probably whose sole job it is to work with print management. They're probably going to have more than just one person that deals with security, network security and things like that. So, and definitely consider professional certification, which is what you're going to do in this class. Skills to acquire, they say: installing, configuring, and troubleshooting server, understanding the characteristics of media, understanding network design and protocols, understanding how networks interact, and constructing a network with client, server, media, and connectivity devices. So they say pick one or two areas of concentration. Specialties that are currently in high demand: network security, that's a big one right now. Convergence, because more and more places are unifying all of their stuff into one network. In-depth knowledge about one or more network operating systems. This is an area that you can kind of specialize in too, because there are so many different operating systems. It's hard to become an expert in all of them. If you're going to go into most of the business world, Microsoft Windows is the way to go. However, if you're going into an engineering field, Unix and Linux is something to look at. If you want to work for a graphics design company, I would definitely know some Mac OS X server, because in that industry, Mac still rule the world. Wireless network design is another one. There's a new specialty where people go into businesses and tell them how to design their wireless. Now that's for a bigger place like here. When they decided to do wireless here, they had a company come in and try to tell them the best places to put the wireless to cover the most people. And then configuration of routers and switches. You can specialize in routing and switching in the Cisco side of things, getting your CCNA, things like that. So also work on your soft skills. These are important to networking, but they're not easily measurable. Soft skills include things like dependability, teamwork, oral and written communications. Customer relations is going to be the big one I'm going to say there. If you're in a small shop as the computer guy, you're allowed to be a little quirky, but you're going to have to talk to people. So it is important that you learn how to explain things that a non-technical person can understand. I'll use the juvenile court again as an example. My boss at the juvenile court was a judge. Doesn't know the first thing about computers. When I got there, they had an old Novell server. We needed a new server. I had to explain to him why we needed a new server, and I needed to explain it in a way that he understood. If I had just looked at him and said, well, because this one's only got a gig of RAM and a 50 gig hard drive, he wouldn't have understood that. He wouldn't have known what that meant. But by me saying you're almost out of space, and if you keep arresting people, the system's going to crash, then he was able to understand, what I'm saying there. So you've got to figure out a way to be able to talk to your audience. If you become a network administrator at a small or a medium shop, it is a high possibility that you're going to have a boss who is not a technical person. So being able to communicate with them what your needs are and what you need and explain it so that they'll understand it is important. And that may not be as important if you work for a huge place. If you're the Active Directory manager for the LSU main campus, you may never see anybody, because you may not be dealing with anybody but other technical people. And if you're dealing with another technical person and you say, I need a new server because the hard drive crashed in this one, well, that may be good enough. They may understand that. So there are several different certifications that you can look at. We're going to look specifically in this class at Network Plus, but there are others. Microsoft has a networking certification. Cisco has CCNA, which some of you may be looking at after this class. CCNA is a good one, but it's hard. I'm not gonna lie to y'all. That's a tough cert. And then the slides don't talk about it, but there are more upper level certs beyond Network Plus. Network Plus is generally the entry level certification into the networking area. Reasons to pursue a cert: better salary, greater opportunities, professional respect, and access to better support. I don't know so much about the last one. One reason I tell students I think it's important that you get these certifications is that you may not live here. Let's say you decide to move somewhere. You move to Anchorage, Alaska. Well, I'm obviously biased. I think our program at BIPSI is really good. But somebody in Anchorage, Alaska is not going to know the first thing about Bossier Parish Community College. But if you walk in and apply for that job and show them you've got your Network Plus, well, they know that you had to learn a standard set of skills that is the same across the entire world. You took the same test everyone else with that certification took. So if you passed it, it means you have the mastery of this certain number of skills. The other reason is that, technology is a booming field. In our economy right now, with absolutely almost everything going down, the two fields that are doing well are information technology and healthcare. People are always going to get sick, and now, because of the way that we've become as a society, they're always going to need computer people. We're never going to get away from those. I was going somewhere with that. Oh, yeah. By having those certs, that's a good thing to be able to put on your resume. Because, if you may apply for a job and there may be 30 people apply for it. Well, they may only decide to interview 5 of those. So you need things on your resume that stick out that are going to make you look better than the other folks, so that you get in the pile that gets to actually come in for an interview. Because you may know the stuff, but if I'm looking at these and I've got 30 resumes and 5 of them have Network Plus and it's a network job, chances are those are the 5 I'm going to interview. Even though you may know more than one of those, you're not going to get your chance because yours is going to go in the trash before you get in the door. So anything like that, any certification you can pick up or certificate along the way is a great thing to do to add so that you've got a good, well-developed resume. Especially if you've not been in the field, because a lot of places will take a cert in place of experience. If it's one thing if you don't have a certification but you've got 15 years experience in networking. But if you don't have any experience, you're new in the field, having those certs can count for experience. So places to find a job, search the web, check the local newspaper, visit a career center, attend career fairs, or you may even enlist a recruiter to help you find a job. Something else you might want to consider later is to join a professional association. These will help you connect with people that have similar interests. There are specialized information access if you're in some of these different professional organizations. You get access to publications, sometimes free software and pre-release software. Some even give you access to a hardware lab. Here's an example of some of the different professional associations that are out there. The Association for Computing Machinery is one. AITP, the Association of Information Technology Professionals. IEEE is probably going to be my favorite off of this, maybe because I'm a member of IEEE. Network Professional Association is another one. And then there's Women in Technology International.
Do you like IEEE?
I like the IEEE. As part of our accreditation up here at BIPSI, when we had our program accredited, every faculty member has to be a member of a professional organization. So I picked IEEE to join, and it's given me access to quite a bit of material. So it's been doubly good for me. I don't know, some of y'all know this if you've seen me in other classes. I'm working on a PhD right now myself in network security. And it's killing me, by the way. I totally understand where y'all are at when you're stressed out with classes, because I'm the same way. But IEEE has given me access to a lot of publications I've been able to use in researching for my doctoral classes. It's pretty easy to join. Just go to computer.org. There's all kinds of information on there. As a student, you can join for $20 a year. Yeah. So in summary, Chapter 1 is about basic networks, the types of networks. We talked about LANs, MANs, and WANs. And we gave an example of some of the ways that you share things. We talked about certifications and joining some of the professional organizations. Do you guys have any questions over Chapter 1? All right, so Chapter 2, we're going to talk about the OSI model. And we're going to identify what the standards for networking. We're going to talk about the purpose of the OSI model, and we're going to explain the functions belonging to the OSI model. The OSI model is something I'm about to show y'all, and I'm going to tell y'all you just need to memorize it. You're going to see the OSI model in every single networking class you take your entire career. And you're going to have questions on every single test about it. It is the one thing that, is on A+, Net+, Security+, CCNA, CISSP, all of them are going to have OSI model stuff on it. We're going to talk about the functions of it. We're going to explain how network nodes communicate through the model. We'll discuss the structure and the purpose of the model, and we'll describe the types of addresses covered by the model. So in order for us to have networks that work the way we do, we had to have standards. And standards are documented agreements on how things are going to communicate. And the reason that these become important is not the same companies are making all of the same equipment. Like, for example, all of these computers are Dells. They have Dell network cards in them. If it weren't for the standard of Ethernet, then if we had a computer in here that had a 3-com network card in it, it may not be able to communicate on the network that these would. The internet never would have been able to exist if all these different hardware manufacturers didn't have these standards on knowing how things are going to communicate. So standards ensure network design compatibility. It's important to know that standards define minimum acceptable performance, not ideal performance. A standard means that it will work. It doesn't mean that it will work at the most optimum level. Chapter 2. There are many different organizations that oversee industry standards. The ANSI, for example, applies standards to the different types of network interface cards. The IEEE writes the standards that communication protocols use. Be familiar with the groups of networking standards and understand the critical aspects of standards required by your own networks. ANSI stands for the American National Standards Institute. They determine standards for the electronic industry and other fields. It requests voluntary compliance with standards. Obtaining ANSI approval requires rigorous testing, and all of the ANSI standards are available online. EIA and TIA are another one, the Electronic Industries Alliance. And they are now one company called the EIA-TIA. They set standards, they help write ANSI standards, and they lobby for favorable computer and electronic legislation. When we start talking about wiring and how you put the ends on a piece of wire, all of those are EIA and TIA standards, like what color goes where on a wire. Here they're just saying what I said, that TIA and EIA are together. And the 568 series is the series for installing network cable in a commercial building. IEEE is another one, and IEEE stands for the Institute for Electrical and Electronics Engineers. The goal of the IEEE is to promote development and education in electrical engineering and the computer science field. They host a lot of conferences and symposia and chapter meetings. And they write technical papers and standards. ISO is another one. The ISO wrote the OSI model that we're about to talk about. And it's headquartered in Geneva, Switzerland. The goal of the ISO was to establish technology standards to facilitate global information exchange and other barrier-free trade. The ITU is one that you should be aware of. You probably won't have a lot of dealings with unless you're working for a company that's global. They are a specialized United Nations agency. And basically, the thing to know about the ITU is they define the communication standards for everyone else in the world except the United States. We have the FCC, which is our version of the ITU. That is also why we have different standards on everything than most of the rest of the world. Right. ISOC is one. It's an internet society that works on technical standards. They concern themselves with rapid internet growth, information security, stable internet addressing services, and open standards. The ISOC has been involved in the IP6 transfer that we'll talk about later. There are a couple of different ISOC groups. The biggest one being the IETF, the Internet Engineering Task Force. And they write things on how protocols should work and how standards should work. They have these things called white papers that give you the best practices on how to set something up. Then we've also got the IANA and the ICANN. And these are the groups that are responsible for handing out IP addresses. So these get important when you start talking about the internet. The IANA is the Internet Assigned Numbers Authority, and they assign the groups of IP addresses on the public internet. And they're divided up into 3 regional internet registries. There's the American Registry, the Asia Pacific Registry, and then the European Registry. So ICANN, the Internet Corporation for Assigned Names and Numbers, is a private nonprofit corporation. It remains responsible for IP addressing and domain name management. So this is going to take us to the OSI model. And the OSI model is the model for understanding and developing the network computer-to-computer communications. It was developed in the 80s by the ISO. So it's technically the ISO OSI model if you really want to get acro overload. But it divides the network into 7 layers: physical, data link, network, transport, session, and application. Protocols directly interact with the levels above and below each other on the model. The application layer interacts with the software. The physical layers interact with the cables and connections. It is important to understand that this is a theoretical representation. By that, what we mean is that you can't actually look at a network and say, this happened here, this happened here. But this is a way for us to be able to understand how network is communicating so that we can understand how it works. The OSI model is hardware and software independent. Every network communication process is represented. And it uses what are called PDUs, or protocol data units. These describe a discrete amount of data. And they flow from layer 6 to 1. So here is the actual OSI model. You have the application layer at the top, presentation below that, session below that, transport below that, network below that, then data link, and then physical. And each layer interacts with the same layer on the computer that is receiving the data from you. The application layer on the computer sending data sends it all the way down to the physical layer, where it goes to the computer that it's meant for, and it goes all the way back up to the application layer. The application layer, when it sends data down to the presentation layer, the presentation adds something to it. The presentation layer at the other end is what that's intended for. So it's the application layer is the top layer. And we're just about out of time, so I think we will stop on slide 19, which is, just before we go into what each of the layers do. But I will close on this. This OSI model, you're going to have to know the layers and the numbers backwards and forwards for the test. They're numbered with physical at the bottom is layer 1, all the way up to layer 7. You will get questions on the test where they say this is something happened at the network layer. You'll get questions where they just say this is a layer 3 protocol, and they expect you to know layer 3 is the network layer. So you got to make sure, put your numbers beside it and memorize it. The book gives a different way. Come up with a mnemonic that works for you. The way I learned it a long time ago was from the top down, and it's all people seem to need data processing. I've heard it the other way around that says, please do not throw sausage pizza away. Either way you want to learn it, as long as you learn this thing so that you know the layers of the model backwards and forwards, you'll do well. All people seem to need data processing.
And application is 1?
7. Application is 7. Physical is 1. So do y'all have any questions up to slide 19 in this section?
Not so far. They're gonna come to me though.